Aim of the experiment is to design and verify half adder and full adder. So the apparatus required is digital IC trainer, which includes all the components, power sources and also breadboard, single strand cables, banana to single strand, IC of 7486, 7408 and 7432.
We will be discussing the theory part of half adder, full adder. Systems such as computers work using binary numbers, which consist of 0 and 1. When binary numbers are added using the operation of binary addition, which will be performed using logic circuits and instead of manual calculations, and it is performed using combinational logic circuits. So, during binary addition, two outputs are produced, that is, sum and the carry. First one is the sum, which gives the result of addition, and second is the carry, which will be represented the overflow when both outputs are 1. So, these circuits that performs the binary additions are called adders. Addition follows simple rules similar to decimal addition. So, when 0 is added to 0, the result is 0. So, both sum and carry are 0. When 0 is added to 1, or else 1 is added to 0, the sum is 1 and the carry is 0. However, when 1 is added to 1, the result becomes 1 0 in the binary. So, the sum is 0 and also the carry becomes 1. So these are the basic rules which forms the foundations of designing the half adder full adder circuits. Next, we have already talked about the combinational logic circuit. A combinational logic circuit is a circuit in which the output depends only on the current input values. Also, it does not depend on the previous input and it does not carry any memory elements. Half adder and full adder are the examples of combinational logic circuit because their output depends only on the present input values. We will be seeing the half adder. So, a half adder is a simple type of adder which will use two binary inputs. Usually, we will be representing it using A and B. So, it produces two outputs. As we all know, sum which represent the result of addition and the carry which represent the overflow. So, the sum output is obtained using XOR gate because XOR gives output 1 when inputs are different. Also, the carry output is obtained using an AND gate because AND gives output 1 only when both inputs are 0. So, the Boolean expression for half adder are sum equals A XOR B and carry equals to A and B. Next is the full adder. Full adder is an advanced adder carry. It is used to add three binary inputs, namely A, B and C carry input C. It produces sum and carry output here. So, a full adder can be constructed using two half adders and one OR gate. The first half adder adds input A and B and the second half adder adds the intermediate sum. Here first adder adds input A and B and second half adder intermediates the sum with carry input C. So the final carry output is obtained using OR gate. The Boolean expression for full adder are sum equals A XOR B XOR C and carry output equals AB plus BC plus ACE. Full adders are widely used in multi-bit binary additions, especially in computer and digital circuits. So, next we will be seeing, we are comparing the half adder and the full adder. Here, half adder adds two binary inputs, as we all know, A and B, and produce sum and carry outputs. It also uses XOR and AND gate, and its circuit design is also simple. However, it has a limitation, that is, it cannot accept or handle carry from previous stage. That is, it cannot accept carry input from a previous stage. So, it is mainly used for single bit addition. Next is, on the other side, we have seen full adder. So, full adder adds three inputs. That is, we all know A, B and carry input C. So it produces sum and carry output. It also uses XOR and OR gates. So the circuit is slightly more complex. But the major advantage is that it can accept carry input from the previous stage and also making it suitable for multi-bit addition, which we will be using in computers and digital systems. Thank you.
Now we move towards the circuit connection for half adder. This is the circuit diagram for half adder. This device is called IC Digital Trainer Kit. This part is the input switches and this the output indicators. We use two ICs for half adder, that is IC7486 and IC7408. Insert IC7486 in the first IC socket and IC7408 in the second IC socket. Now, the first part becomes XOR gate and the second part becomes AND gate. Connect the seventh pin to ground in both the gates. Pin number goes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The 14th pin is connected to plus VCC in both cases. Now we have A and B. It is going as input to XOR gate. So here pin 1 and pin 2 we are considering as A and B. So A and B is going to XOR input. That is, we should connect A to input 1 here and B to input 2. So now here our sum is C, that is pin 3. So that is our output. So we are connecting 3 to output. This is our output, this is our input. Similarly, according to our circuit, we have AB connected to AND gate as well. So we will connect A and B to AND gate and its carry will go to output. So A is connected to AND gate input 1 and B to AND gate pin 2. Now its output is going to carry. We will consider output as 3. So we will connect 3 to output, that is carry.
Now we are going to verify the truth table of half adder. A half adder is a combination circuit that adds two binary inputs A and B. It produces two outputs, the sum and the carry. The Boolean expression for half adders are sum equals A XOR B, carry equals A and B. XOR means the output is 1 only when inputs are different, and means the output is 1 only when both inputs are 1. Now let us verify the truth table of half adder step by step. These are input and these are outputs. This is A, this is B, this is output sum and this is output carry. First we will give A as 0, B as 0, A 0, B 0. We are getting sum 0 and carry 0. No lights are there, so 0, 0. We'll note it down, sum 0 and carry 0. Next we have to give A as 0 and B has 1. A 0 and B 1. We are getting sum has 1, carry 0. 1 and 0. Next we have to give A1 B 0. A1 and B 0. We are getting sum 1 and carry 0. 1 and 0. Next A1 B1. A and B both are 1. We are getting sum 0 and carry 1. 0 and 1.
Now we move towards full adder. This is the circuit diagram for full adder. We have 3 input, that is A, B and C, and 2 output, that is sum and carry. Pin 1 is connected to input A. Is connected to input A. Again, the pin 1 is connected to AND gate input 1. Pin 1 is connected to AND gate input 1. XOR gate pin 2 is connected to input B. XOR gate pin 2 is connected to AND gate pin 2. Pin 2 is connected to AND gate pin 2. Now XOR gate pin 5 is connected to input C. Pin 5 is connected to input C. Next, pin 3 of XOR gate is connected to pin 4 of XOR gate. Pin 3 of XOR gate is connected to pin 4 of XOR gate. XOR gate pin 4 is connected to AND gate pin 4. XOR gate pin 4 is connected to AND gate pin 4. XOR gate pin 5 is connected to AND gate pin 5. XOR gate pin 5 is connected to AND gate pin 5. AND gate pin 3 is connected to OR gate pin 2. AND gate pin 3 is connected to OR gate pin 2. AND gate pin 6 is connected to OR gate pin 1. AND gate pin 6 is connected to OR gate pin 1. XOR gate 6 is connected to output, that is sum. XOR gate 6 is connected to output, that is sum, and OR gate output is connected to carry. This completes the circuit connection for full adder.
This is verification of truth table for full adder. A full adder adds 3 inputs A, B and carry inputs called C in. It produces 2 outputs sum and carry. This is the Boolean expression, that is sum is equal to A XOR B whole XOR C in, carry is equal to A and B or C in A XOR B in brackets. These are the inputs. This is sum and this is carry. First we will give all has 0, A, B, C in 0. We are getting sum 0 and carry 0. We'll write it down 0 and 0. Then we will give 0, 0, 1. C in has 1. We are getting sum 1, carry 0. 1 and 0. Then we have to give 0, 1, 0. B has 1. Then we'll get sum has 1, carry 0. 1 and 0. Then 0, 1, 1. B and C has 1, 1, 0, 1. So sum 0 and carry 1. We have 1, 0, 0. A is equal to 1. Now we are getting sum 1 and carry 0. Then 1, 0, 1. A and C has 1, 1. B is equal to 0. 0, 1. We are getting 0 and 1. 1, 1, 0. We have 1, 1, 0. Now again we are getting 0 and 1. And at last all are 1, 1, 1. We are getting both has 1, sum 1 and carry 1. So we can see that the sum depends on XOR operations of all three inputs and carry is generated when at least two inputs are 1. Thus, both the half adder and full adder truth tables are verified successfully. These circuits form the foundation of all digital additional system in computers.
We will be discussing about the factors affecting the experiment and expected viva question and answers. These are the factors affecting the experiment. Errors due to improper power supply. Digital ICs used in half-adder and full-adder experiments requires a stable DC power supply. If the power supply voltage is too low or too high, logic gates may not switch correctly. Output levels may become undefined. LEDs may glow dimly or not glow at all. ICs may overheat or get damaged. To prevent this, use a regulated DC power supply. Verify voltage using a multimeter before switching on the circuit. Avoid loose power connections. The second one, loose or improper breadboard connections. Improper insertion of IC pins, jumper wires, or LEDs may create open circuit, short circuit, wrong logic levels on the breadboard. Even a small loose connections may change the output of a half adder or a full adder. The common problems are broken breadboard strip, wrong row connections, adjacent row shorted accidentally. To prevent this, double check all the wiring before powering the circuit. Use color coded wires for inputs, outputs, VCC, and ground. Test continuity if outputs are unstable. The third one, wrong IC placements or pin configuration. Each logic IC has a specific pin diagram. Those are XOR gate IC7486, AND gate IC7408, OR gate IC7432. If the IC inserted in the wrong orientation or if the pin number are confused, input may connected to the outputs, power may apply to the incorrect pins, the IC may fail permanently. To prevent this, check the circuit diagrams before wiring. Identify the notch or a dot marking on the IC. Confirm pin number carefully. Fourth one, faulty logic ICs. A damaged or defective logic gates IC can produce incorrect outputs even if the circuit is wired correctly. IC may be damaged due to electrostatic discharge, overheating, excessive voltage, mishandling, repeated use in lab sessions. To prevent this, test ICs before use. Replace suspected faulty ICs. Handle CMOS ICs carefully using anti-static precautions. The fifth one, propagation delay of logic gates. Logic gates do not respond instantly. Every gate has finite propagation delay between input change and output response. This because important in full adder because multiple gates are connected in series. Carry out depends on several intermediate signals. The total delay may cause temporary glitch in the sum and or carry output. To prevent that, allow enough time before observing outputs. Use an oscilloscope for detailed time analysis. The sixth one, incorrect observation of LED outputs. LEDs are commonly used to indicate sum and carry outputs. Errors may occur because LED's polarity is reversed, current limiting resistance is absent, LED is faulty, user misreads dim illumination. To prevent this, verify LED polarity. use suitable resistors, replace dim or damaged LEDs, confirm output with multimeter if necessary. Human errors. Human mistakes are among the most common causes of the incorrect results. Example: wrong truth table entry, incorrecting the wirings, misreading IC pin numbers, wrong interpretation of outputs, failure to check carry input in full adder. To prevent this, follow the circuit diagram carefully, cross check truth tables, record observation systematically, repeat the experiment to verify result. The eighth one, the errors in carry generation of full adder. The full adder includes an additional carry input compared to the half adder. Because of this, incorrect carry inputs connections may produce wrong results. Students may forget to change carry input during the truth table verification. Intermediate carry signals may confuse the final carry output. To prevent this, carefully label carry input and carry output. Verify all the 8 possible input combinations. Cross check the truth table. Now we will be discussing about the expected Viva question and answers. What is a half adder? A half adder is a combinational logic circuit that adds two signal binary digits and produces two outputs, sum and carry. What are the outputs of a half adder? The outputs are sum is equal to A XOR B, carry is equal to A and B. What is a full adder? A full adder is a combinational logic circuit that adds three binary inputs A and A, B, and carry in. What are the outputs of a full adder? The outputs are sum is equal to A XOR B XOR C. Carry is equal to AB plus BC in plus AC in. Why is a half adder called half adder? It is called a half adder because it cannot handle a carry input from previous stage. Why is a full adder more useful than the half adder? A full adder can add carry input along with two binary bits, making it suitable for multi-bit binary addition. Which logic gates are commonly used in half adder circuit? XOR AND gates. Which logic gates are commonly used in full adder circuits? XOR and OR gates. What is the function of XOR gate in adder circuit? The XOR gates generates the sum output. What is the function of the AND gate in half adder? The AND gate generates the carry output. Why is propagation delay important in full adder? Because the full adder contains multiple stages of gates. Delay accumulates and may cause temporary incorrect outputs. Why do LEDs sometimes glow dimly in digital experiments? This may happen due to low supply voltage, weak output current, wrong resistor value, or loose connections. What is the typical power supply voltage for TTL ICs? TTL ICs usually require plus 5 voltage DC. What happens if the VCC and ground are connected incorrectly? The IC may not function properly and can even get permanent damaged. What is the role of carry input in a full adder? Carry input allows additional of a previous carry bit, enabling multi-bit addition. How many inputs combination are there in half adder? There are 4 input combination because it has 2 inputs. How many input combinations are there in full adder? There are 8 combination inputs because it has 3 inputs. Which IC is commonly used for XOR gate? IC7486. Which IC commonly used for AND gates? IC7408. Which IC is commonly used for OR gate? IC7432. Why do we use current limiting resistors with LEDs? To prevent excessive current from damaging the LED. What is the main limitation of a half adder? It cannot accept carry input from a previous stage. What is the main advantage of a full adder? It can be to form multi-bit adders. What is the hint by combinational circuit? A combinational circuit is a circuit whose output depends only on a present input. What are the practical causes of errors in this experiment? Practical causes includes loose connections, wrong IC placements, faulty ICs, floating inputs, unstable power supply, propagation delay, and human mistakes. Thank you for watching the video.